part 2 of the sensors demo video within the same video, just different recording. I'm going to talk a little bit about the why I chose certain values and the signal processing behind the system itself. So a lot of this system involves, well, this is one of the pressure sensor in here is actually a enclosed resistor, and then every other like sense that these two use when it comes to their thresholds are also resistors. So essentially all four of these are using the constant 5-volt input as a means of relating the voltage, the current signal that is like being sent through it, and thereby voltage like drop across the system itself, as or even certain parts of it, as the means of gauging their respective values. So whether it be the wet thermistor, or it's not a wet, there's a thermistor in this one as well as a thermistor here, both for temperature, and the DHT11 features a wet resistor that changes resistance based on the amount of moisture it's exposed to, and that is how you're getting the humidity on here. Although I've found that the resolution of both the thermistor and the wet resistor are pale in comparison to the actual I2C over here, which already has a much more sophisticated setup. But the thermistor featured on this and the piezoresistive pressure sensor both have much better resolution and come up with more detailed values, which is why I've chosen to average the two temperature sensors so that there's like an element of redundance. And also the thermistor is not so bad that I feel like it'll be holding back the reading. It'll serve as an anchor so that if this one is overly sensitive or is damaged, it'll have a more reliable neighbor to piggyback off of, so to speak. And basically, like I was saying, the signal that is sent through this cord here into the third GPIO and the SDA like signal for the I2C, both are how we get the values that are being read in the serial monitor or even set somewhere else. Now, when it comes to the water level sensor, is much different because if you'll notice, there are traces, and all of these traces you can see, these copper ones they're all open, as in like they connect, they don't connect to anything in particular. And there are secondary traces. You can't tell that they're there because it's sandwiched between the printed bit, but there are secondary traces between each and every one of these that essentially are closed. So the idea is that the water will create a short and interfere with the constant signal that would normally be in the control environment of this sensor. So the difference in the expected signal and the produced signal is how the water level sensor gives you the value it does. The reason why I think this water level sensor is great for the intention of this project is because of its ability to essentially give you the baseline level of wet and not necessarily exceed that. So it is cheap, yes, and it's very low profile and low budget, but at the same time, it doesn't need to accomplish much, because the reason why, and this leads into the reason why the threshold is 1,000. When I took in part 1, when I took the water level sensor outside of the cup, you could see that it immediately dropped to 185, and that's because the amount of live exposure to liquid uh, greatly influences the level of signal distortion that it experiences, in reference to the expected signal. Not in terms of like noise. And that means that do, like ideally this would be the most exposed sensor of the system in actual application. Do, or even like, I don't know, stray bits of water may cause the value to rise, but unless it's actually submerged in liquid, which I imagine it would have a small exposed ring with holes on it so that it like drains but also fills slowly, this would sit there, and unless you had actual constant water flow, it wouldn't give you any readings above 1,000, which indicates rain successfully. Those all three of these play a big part in giving you those conclusive values, and ultimately I think that as far as sensors picks go, these two are very well are very good. This one is, its humidity is great, but the temperature sensor is not so much. The thermistor in there is not so much. So I wouldn't peg that in the same category as this, but nevertheless, it is still a valuable asset.